Okay, so the most important thing in Spark, the way they could build that distributed data set and ability to reference the distributed data set is for the resilient distributed data sets. So how they reduce the need to write to the disk is through RDDs. So I'll just explain to you a little bit of how it's actually processed, and then you can understand why is it much more efficient. So whenever the mappers are processed, they're read from the disk, and then the intermediate results are again written to the disk. And then that goes through shuffle and sort and again read from the disk. And then that result is produced as written is sent to the reducer, which is again writing to the disk. So if you see how many times the disk is being used, there's a lot of, and disks are slow. There's a lot of overhead, and disks are definitely very slow. So if you look at the way Spark is actually processing this, so there is only a distributed memory. So instead of writing to disk, it's writing to a distributed memory. And the most important thing in this is it's a immutable RDD. So what happens is if there is any change to it, it creates another RDD. It doesn't change the existing RDD because it causes a lot more problems for it. So that's why whenever there's an action processing or something that happens, it's written to memory and it's an RDD that's created. That's why it's much more efficient than a lot of disk processing. So all the mappers will produce this RDD, which is processed in the next stage, and another RDD is produced. That's why Spark is very memory intensive. You need a lot memory in your processing Spark compared to MapReduce, because whatever the results are, the intermediate results are still in memory until your program dies and you write to the disk. So, and the other thing is I have to explain about the DAGs. So there is a directed acyclic graph that's actually built when you're processing Spark code, wherein it doesn't process until it finds an action or a final step or a save or a reduce phase or something like that. It doesn't process, and all of them are happening iteratively. So if you have like 5 mappers, so what I meant by this is if you have 5 mappers, in the iteration 1 you have a mapper, in the iteration 2 you have a mapper, iteration 3 you have a mapper. The way MapReduce produces is it does the mapping, saves it to disk. Again, another mapper starts, saves to disk. Another mapper starts, saves to disk. Instead, all of them are run simultaneously in the memory inside Spark. That's why it's faster, because all these actions, so all these mappers are produced are run one after the other in memory, and then the action happens, and then that an RDD is created. So there is a certain amount of efficiencies that are built. So that's why it's fast, a lot faster than typical MapReduce. And this is interactive querying, wherein you have we have a Spark already sitting in memory, and you're querying it for online results. That's why it's very interactive, as well as I don't know if you have ever looked at Zeppelin notebooks and all those notebooks. So, but you can actually have a notebook to query your Spark RDDs, and you can constantly keep querying those RDDs, and it stays in memory. And you can have a persistent RDD too. So I think I spoke about the Hadoop. I spoke about a little bit of Spark. So I think we stopped at this part in the previous session, wherein this is what an RDD is. It's an in-memory computation. It's lazy evaluated. So until an action happens, the RDD is never evaluated. So even if you write 1500 operations in it, until it sees an action, then it goes and processes everything. Until that action happens, nothing processes. What an action is, I'll explain to you in the later sessions, but you have to understand it's a lot of lazy evaluation that happens in Spark. It's fault tolerant because if it crashes, it can come back, or it can be reevaluated very easily. It's immutable because it's saved. It's actually shared between multiple nodes, and it's a memory copy, so it needs to be immutable. It is partitioned. So an RDD has many partitions which are sitting in many boxes. So it's a partition data set. You can persist an RDD. You can have a persistence, and it's a coarse-grained operations. It provides a lot more coarse-grained operations, which I will go through in the next in the next session. So there's a map filter. Okay, these I want to explain in detail in my next session, how which ones will trigger a shuffle, which ones don't trigger a shuffle, which one is a narrow operations, on all those stuff I'll explain to you in my next session, then we go in depth in Spark. So I think I spoke about all this stuff in Spark, right? Yeah, good. So this is the session, a brief introduction to Spark. I'll go in depth of how Spark is, how you write Spark programs. You can actually install Spark in your local boxes and actually run. It's very, very simple. You just need one master and one worker, and you can actually test it yourself, how it's processed, how it looks and all that. I'll try to do it on my laptop, or I'll try to create an Amazon box and test it over there. So you can easily test it without much problem. Okay, I'm going to stop the recording and take questions.